8th grade math, test 7, study guide. Problem number 1. So we're adding two fractions together. One is we're dividing two fractions. They're both negative. So problem number 1, we have negative 1/3 divided by negative 1/4. When I divide by fractions, I multiply by the reciprocal. Just flip the second one upside down, and then I do my factor trees, but this is 2 times 2 and this is a 3, so they're not going to have anything in common, so I can just multiply. Negative times negative is positive, right? We talked about that, and I got 4/3. We'll check our answers, make sure that an improper fraction is okay, and this time it's not. This time they wanted us to convert, so we divide in and out. 3 times 1 is 3, and then my remainder goes on top. My divisor goes in the denominator, and 1 1/3 is our answer, number 2. We're going to add fractions. 7/10 plus 1/3. This is where we need a common denominator, right? Same size pieces on the bottom. So I look at my factors of 10, 10, 20, 30. The first time these are going to be the same as 30. So I multiply this by 10/10, and I multiply this by 3/3. So 7/10, another way to say 7/10 is 21/30. So the same fraction, right? This one's reduced, this one's not, but it's the same fraction. Over here, 1/3 times 10/10 is 10/30. Now that we have the same size pieces, we have 21 of these and 10 more of these. In other words, we have 31 of these. And again, they wanted to convert that this time, even though that's an okay answer. We divide in and out, and again, we get our divisor goes there, and we get 1 1/30. Alright, number 3. We're going to simplify. Rad 16 plus the square root of 64. Well, square root of 16 is 4, square root of 64 is 8, 8 plus 4 is 12. Done. Number 4. Write the fraction 3/5 as a decimal, so we divide in and out. Put our decimal there, add as many zeros as we need to. 5 doesn't go into 3, so don't start there. 5 does go into 30, and since we're on this side of the decimal, and I have a 0 remainder there, my answer is done, 6/10. Number 5. And I apologize, so the test generator that I use, even though I make most of my problems, I put in a test generator just for the format purposes. But after that, it shoots up here to 5. I apologize. I don't know why it's doing that. It's trying to calculate it so it can fit everything on the least amount of paper. So I apologize. So 4 has to go up here. So be careful of that. Number 5 goes up there. So number 5, Elena needs to cut a square piece of wood with an area of 162 square inches. How long should the sides be? Well, if it's a square, these are the same. So if I don't know something, I let a variable equal that, right? Variable means a missing number, right? A missing value. So if that's x, this is x too, because it's a square. They're all the same. So x times x, or this times this, is how we get area. X times x is x squared. The area, or x squared, is 162. If I need to know x, I need to solve for x. So I take the square root of both sides. We always do plus and minus, okay? However, since this is a length, we're going to go ahead and leave that extraneous solution, that negative, out this time. Because yes, it's right mathematically, but it doesn't make sense for this problem. So we're just estimating the square root of 162 to the nearest tenths. So we just narrow that down, right? 10 times 10 is 100. That's too big. We know 20 times 20. We can do that. 2 times 2 is 4, right? With 2 zeros. 400 is way too big. We memorized 15 squared. Remember that in class? That's 225. That's too big. So it's in between those, 10 and 15. So let me try, let me try 13 times 13. Because it's kind of in the middle of those. So I got 9, 3, 0, 13. And I add these up here. I get 169. 169 is barely too big. So I'm going to go down. I know 12 times 12 is 144. So the square root of 162 is in between the perfect square, 144, which is 12 times 12, and 169, which is 13 times 13. It's in between those two. So it's in between 12 and 13. And a lot of the times that's enough to answer the question right there, right? If you're doing multiple choice, it's 12 point something, right? But it's possible there might be, 12.1 and 12.9 or 12.5. You got to figure out which one it is. So you ask yourself, which one's it closer to? Is it closer to 144 or is it closer to 169? So it's closer to 169. Not super, super close, so I wouldn't say 12.9. Sort of in the middle-ish, but closer to this one. That's about 12.7, 12.6, maybe 12.8. That's going to be enough to get it right on a test, right? That's just 12.7. Okay, next one. Number 6. Number 6 says x cubed is 1,000. And they say to solve. Solve means, what is x? What number goes there to make this side the same number as this, right? That's what solve means. And the way we solve is we make it say x, or we isolate x. So if I want to make x cubed become x, I got to take the cubed root of both sides. Now, this isn't where we do plus and minus. That's when we take the square root. Cubed root, we don't need to do that. So I'm going to multiply something 3 times. 10 times 10 times 10 is 1,000, so the cubed root is 10. Number 7. Given the following numbers, pick the statement that's true. So you have the square root of 101. That's irrational because that radicand is not a perfect square. 2/3, that's rational because if it's a regular fraction, that's a definition, ratio, rational. And then 0.01001 ... So this is going on forever, which could be either rational or irrational. Rational numbers either repeat or end. Irrational, they don't repeat or ever end. Now, since this is a pattern that's always going to be changing, see, I'm going to add another 0 now. This is one of those weird decimals. It's not like this where it repeats the same thing over and over again. Okay? If it repeats the same thing over and over again, it's rational because I can write it as a fraction. But if it's always changing and never ending like pi is, then that's irrational. So I have 2 irrational numbers here. And that's the answer for number 7. So now we got to go back down. So from 7, right, we got to squeeze back down here, over here to 8, back to 8, back to 8. Ocho, write all numbers that apply, write all the names. What? Write all the names that apply to the number 40 over 8. Well, the name of the game is you have to simplify first. 40 over 8 simplifies to just plain old 5. And that's as simple as it gets, just a regular old number, right? That's what we call a natural or a counting number, which means it has to be a whole number, right? Whole numbers are these plus 0. And if I take whole numbers and add negatives, then those are integers. Then if I add fractions and decimals plus all of these, that's what we call all rational numbers, right? Anything that can be written as some type of fraction. And then everything is a real number in 8th grade. So that's the answer for number 8. Number 9, simplify -3 to the -3rd power. Well, we don't think Mr. Dude here, right? Because I'm not multiplying. This is an exponent here. So I have to deal with that negative first. So I'm going to flip it upside down. Notice that -3 is not affected yet, but this negative is. These two are the same number. Negative exponent means flip it and then it becomes positive exponent. But that doesn't affect this negative. That's an actual negative number. So now I have to simplify this. -3 times -3 times -3 is negative times negative is negative. There's an odd number of negatives, which is a negative answer. If there's an even number of negatives, it'd be positive, right? So I have 1 over 9 times 3 is 27, but it's negative. And when you have a negative on top and bottom, you can just put it out to the side. If you had 2 negatives, it'd be a positive answer. Number 10. Number 10 says, rewrite. Oh, we love rewrite, right? That means less work. -9 to the -1st power times -9 to the 3rd power times -9 squared. Rewrite using one base, perfect. That means I don't have to do this last step where I multiply. Okay, I get to stop early. So I copy the base, add the exponents. So let's use teams, because we use teams when we add, right? I got a negative number, positive number, positive number. I have 5 positives and 1 negative. Opposite teams mean subtract. Who has more positives? -9 to the 4th power. And I don't need to multiply that out because of the directions. And I just realized I copied this problem wrong. I apologize. This is actually a negative right here. Sorry about that. The reason I caught that is because I checked my answers. That's same thing I want you to do. Find where your mistake is. I found where my mistake is. My mistake is this is negative, so this doesn't go here. It goes over here. So I have 3 positives, 3 negatives. 3 take away 3 is 0, so it's 9 to the 0 power. And I know anything to the 0 power is 1, but the directions weren't to simplify. The directions were to rewrite using 1 base. So, good thing I checked my answers. I caught my mistake. Next problem. Alright, so we are on, which one did we just do? Number 10, we're on number 11. Number 11 says we're going to simplify 3 to the 4th power over 3 to the 3rd power. 3 to the 4th power over 3 to the 3rd power. We're dividing powers with the same base, so I copy the base and subtract top exponent minus bottom. That's the shortcut for dividing powers with the same base. I'm not subtracting these numbers, I'm subtracting their exponents, which means I'm actually dividing these numbers. 3 to the 1st, and I'm done. 3 to the 1st is just 3. Number 12. 12 says evaluate a to the negative 3rd times b to the 0 for a equals 2 and b equals negative 1. Alright, well, I'll tell you what, b to the 0 is just 1, right? Cross out your 1s. A to the negative 3rd is 2 to the negative 3rd. 2 to the negative 3rd is 2 to the 1 over 2 to the 3rd, which is 1/8. Number 13. Simplify x to the 7th to the negative 3rd. And this is where I have power next to a power, so I copy the base, multiply the exponent. And if it says simplify, negative exponents are not simplified, so since it doesn't say rewrite, it says simplify. I have to keep going until I'm done. There's 13. Number 14 says m times m to the 4th times m to the negative 1st all over m squared. So, I'll do the top first. Copy the base and add the exponents. Well, this is a positive one. Positive one and negative one just cross out, so I got m to the 4th. Or you can go out to the side and do teams. You're going to get the same thing. Whoops. Sorry about that. Let me say this again here since I lost you. So we have m to the 1st times m to the 4th times m to the negative 1st. So the negative one and the positive one and the negative one cross out. So I have m to the 4th on top. And on the bottom I still have m squared. Okay. Now I copy the base, subtract the exponents. Done. Alright, number 15. Number 15 says express 14 million in scientific notation. Is that million? Let's check. Hundreds, thousands, millions. Yep, 14 million. We're going to write down scientific notation, meaning my decimal needs to go here, but it's got to be the same number. So what I do now, if I had 1.4, if I put my decimal there, that's the same as multiplying it times 10 to the, how many times did I move it? 1, 2, 3, 4, 5, 6, 7 times. 10 to the 7th. Done. Now it's not 10 to the negative 7th because 14 million is a big number compared to 1, not a small number. 16. We're going to write 9 and 35/100 times 10 to the negative 8th in standard or decimal notation. Now, this is a really small number because it's a negative exponent. So I'm going to take 9 and 35/100, and since it's a small number because it's a negative exponent, I'm going to add zeros on this side, just a bunch. It doesn't matter how many, because if I add too much, they're going to go away. If I don't add enough, I'm going to just add a couple more, no big deal. So my decimal's here, so I'm going to move it 8 times. Negative 8 means this way, or smaller, instead of larger. So I go 1, 2, 3, 4, 5, 6, 7, 8. Now another way to think about it, shortcut, those of you that like to take shortcuts, you're going to move it 1 time, so there's one of them, so just add 7 zeros. So I go like this, 1, 2, 3, 4, 5, 6, 7, and then that last one counts for the 8, and don't forget the 35, and this is how we do it. Number 17. Alright, 17 says, which statement is true below given the two numbers? So we have A, which is 0 point, let's count these zeros, watch. So we're going to count these. We got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5. And then 6, 78 after that. Okay, so you see how I do that? I'm just counting the zeros. B, I have 5 and 76/100 times 10 to the negative 6. 5 and 76/100 times 10 to the negative 6 power. Okay. If I'm going to compare these two numbers, I need to put them both in scientific notation or both in standard notation. I'm just going to put them in scientific notation first because, like, let's say this was a 60 over here. I don't want to write 60, 59 zeros. So anyways, I'm going to put this one in scientific notation. So I have to move the decimal. Remember, it's got to go to the right of the first digit that's not 0. So I got to move it right there. So I go 1, 2, 3, 4, 5, 6 times. This number is the same as 6 and 7/800ths times 10 to the, remember I moved it 1, 2, 3, 4, 5, 6 times. 6 power, except this is a small number, not a big number, so that's negative 6 power. So now I can compare these two. It's all about the exponent. Whichever exponent is larger is automatically a larger number, regardless what the coefficient says. But in this case, the exponents are the same, aren't they? So now I look at my coefficient. 6 and 7/800ths is obviously more than 5 and 76/100ths. So A is larger. So my answer for that one, the numbers are the same. Nope. You cannot compare it. That's not true. A is bigger. Yes. A is smaller. No. So the answer for 17 has to be C. Number 18. Write the two numbers below in scientific notation. So 65 and 1/10 times 10 to the 21st is not in scientific notation because, like we said earlier, the decimal has to be to the right of the first number that's not 0. So I have to move it one time. So this is where I draw 3 arrows. I'm going to rewrite 65 and 1/10 and drop down 10 to the 21st power. Let's drop that right away. So I'm going to rewrite this. It's going to be the same number. So 6.51 times 10 to the first is the same number as this. These are the same thing. I moved it one time. 65 is bigger than 1, so it's positive 1. See, this would be a negative 1, right? I'm moving that one time, but that'd be a negative 1. And what's left now is just to combine my tens or multiply my powers with the same base, add the exponents, and there's my answer. Now, for 18, we're going to write 4/10 times 10 to the 5th, also in scientific notation. Again, my decimal's not in the right spot. It's supposed to be to the right. So I have to, again, move this one time. I'm drawing 3 arrows again, right? Don't forget about that, 10 to the 5th power. So this is the same as 4 times, not 4 times 10, that's 40, not 0.4. It's 4 times 10 to the negative first. Or that's like, remember, flip the negative exponents, like dividing by 10. 4 divided by 10 is 4/10. So, just like the last one, I combine my tens, but this time they're opposite teams, so I subtract. And 4 times 4 times 10 to the 4th power is that number in scientific notation. 19. A passenger plane travels at 7.41 times 10 to the 2nd feet per second. So this is feet per second. Feet per second. That's a rate. If they say per and they give you 2 units of measure, that's a rate, the R speed. Okay. The plane takes 1 and 27/100ths times 10 to the 4th seconds to reach its destination. That's a time. So they give us rate, they give us time. They say about how far. We need to know distance. That's what we're figuring out. About how far? Write your answer in scientific notation. So we know that distance equals rate times time. So this time we don't have distance, we have rate. Whoops, let me rewrite that. We don't have distance, we have rate, which is 7 and 41/100ths times 10 to the 2nd. And we have time, which is 1 and 27/100ths times 10 to the 4th power. So if I multiply rate times time, I get distance. They gave me rate, they gave me time, they asked me what's the distance. So this is a multiplying by scientific notation number problem. If they don't give you distance, you multiply. If they don't give you distance, you multiply. If they give you distance, you divide. Distance divide, DD. Try to remember that. So I have distance equals, I got to multiply these two. I have 7 and 41/100ths times 1 and 27/100ths. And just because I'm running out of time here, my next class is about to start pretty soon, so I'm going to go ahead and multiply that out. 9.41 times, righty then. And what we're going to do here, we're going to write in scientific notation. Let me do this again. 7.41 times 1.27. So I got 9.4107 times 10 to the 6th power. Okay, and it looks like in the answer they just rounded to the nearest hundredths there. So I'm trying to figure out why it's rounded to the nearest hundredths. Well, they just chose to round to the nearest hundredths. Okay, this one I got from the test generator. So yeah, they just rounded. Okay, so there's the answer. Next one, number 20. Because did it say in the directions about how far, write your answer in scientific, it didn't say it around, so I'm not sure why they left that last couple decimal places out of there, but it's the same answer. Only one of them will work if you did that. You're only going to see one right answer on your multiple choice test, so I guess that's okay. A radio signal travels at a rate, they give us a rate, 3 times 10 to the 8th, and they call it 3.00, but that's just 3. They tell us it's a rate, okay? They give us rate. They say, how many seconds will it take? How many seconds? That means they're asking us to find time. I want you guys to do the same thing on your test. Write down what you have, write down what they're asking you to find. How many seconds will it take for a radio signal to travel from a satellite to the surface of Earth if the satellite is orbiting at a height? They give us a height. Now height, so you know, is a distance, right? It's just a distance. They give us a distance of 1.35 times 10 to the 8th power. So, like I said before, if they give you distance, you divide. If they don't give you distance, no distance, you multiply. Okay? And let's see why that makes sense. Distance equals rate times time, right? If they give me this and they give me this and I have to solve for that, I have to divide both sides to get time. Okay? So remember this, when you divide, if they give you distance, you divide. Distance is on top. Distance is always on top. Distance on top. Okay? So distance is always on top. I know that's 2 words right there. Okay, so let's see how we do this. If they give me distance, I put it on top. If they give me distance, I always put it on top. And whether they give me rate or time, it doesn't matter. I'll always put that one on the bottom. Okay? Now we can make sense of that by using distance equals rate times time, but these videos are supposed to be short, so let's just get to the point. Distance on top, divide. No distance, multiply. So I'm going to divide my coefficients here. I go in and out, put my decimal. I got 4, and I got 45 hundredths as my coefficient. And then 10 to the 8th divided by 10 to the 8th. I copy the base, subtract the exponents, I get 10 to the 1st, which is just 1. So I really just have 45 hundredths. That's it. It doesn't say to write your answer in scientific notation like the last one, so I can leave it in decimal notation here. It's 0.45 seconds, and I know on your answer it says 0.450, which is the same thing, isn't it? And I hope that helped.